This meeting is being recorded.
For Chapter 7, Problem 9, we're told that this reaction exhibits a second-order rate equation. So I've drawn out what we could imagine that rate equation to look like based on this information. So we would have the rate is equal to some constant K, and then times the concentration of our alkyl halide, which is this structure over here, our chlorocyclopentane, and also times the concentration of base. So that's where we know that it is second order, first order with respect to the alkyl halide, first order with respect to the base. So we're asked here in part A to determine what would happen to our rate if the concentration of our chlorocyclopentane were tripled and our concentration of sodium hydroxide, which is our base, remains the same. So we can plug in to our rate equation. We could say that the rate would equal 3 times the concentration that we're relating this to, and then our sodium hydroxide concentration stays the same. So we could assume that we would have 3 times the rate if we tripled our concentration of our alkyl halide. We're asked then in part B, what would happen to the rate if the concentration remains the same? So now our rate will be 1 times the concentration here, and our concentration of sodium hydroxide is now doubled, so 2 times the base. So our rate we should expect to be 2 times our original rate. Then in part C, we say what happens to the rate, what happens to the rate if the concentration of our chlorocyclopentane is doubled, and then our concentration of sodium hydroxide is tripled. So we would say the rate, and this first reactant, this is doubled, and then our sodium hydroxide is tripled. So we would expect 6 times our original rate.